The Dishonored saga has one of the most fantastic UI designs out there up to this day. Everything fits well together, from the style of the environment to the way parts of the story are presented through it. There is no doubt that Arcane Studios did a great job on designing it in both main games. While a lot of elements have changed between Dishonored and Dishonored 2, besides the overall style, one thing that is persistent is the Radial menu. It was my preferred way to choose items and powers in the first game, and recently also in the sequel. The fact that Dishonored uses a large number of items such as pistols, crossbows, utilities, and 12 different abilities made it necessary to have such a menu, although the classic 1 through 9 menu is still available. That being said, the developers found the best way to ease the action of selecting items, which is in fact the main purpose of a Radial menu. Okay, but what's so cool about this nitrogen? It is true that from the outside it might not seem like something very special, and in fact it isn't really, especially if the design isn't done well, but from a technical point of view, it is not the easiest thing to come up with, particularly if your vectorial math and algorithm logic aren't on point. Let's talk about the fundamental logic and math that make Radial menus so cool. Before talking about the math behind the Radial menu, let's imagine how it works. Firstly, let's get a center point. This is usually the middle of the screen. Around it, we will put 5 items. This is just a random number. For the mouse position, we will choose a random point for the general case. If we were to draw a line between the cursor position and the center of the menu, that line would cross the boundaries of one of the items, and that would be selected as the hovered item. And that's it. It's not too hard to visualize the concept. Alright, let's start the technical part. First and foremost, let's break this down into 3 parts. Finding out the general direction of the cursor, dynamically creating the items around a fixed point, and selecting an item based on its position and the general direction of the cursor. Starting with finding out the general direction of the cursor. For this task, we are going to be using vectors combined with trigonometry. It is critical that you know that we are working with the monitor coordinates, which look like a normal x or y graph but with its y-axis inversed. When you hear me mention width and height, I will be referring to the dimensions of the monitor. First of all, we will need a vector that we can reference ourselves to. For this, I chose the vector that goes up 1 unit from the center of the screen. In other words, OA vector minus OM vector, where O is the origin of the monitor, the top left corner, A is the point with the coordinates width divided by 2 and 0, and M with the chords width divided by 2 and height divided by 2. Vectorial speaking, by subtracting these two, we are basically constructing a vector that goes up from the tip of OM up to the tip of OA. Then we will have to normalize this vector to keep the direction but make its length equal to 1 unit. We will call this vector the center up vector. Now that we have figured this out, we have to find the vector that unites the center of the screen with the cursor. For that, we will subtract from the position of the cursor the vector OM, which is the same as the one used before. The position of the cursor can be get through code, so don't worry about it. To understand the logic behind this, we will use a random point on the monitor. Now we will also have to normalize this vector so we only keep its direction. Let's call this vector cursor direction. In case you forgot, we have to find out the angle between the center up vector and the cursor direction, and that's very easy. We will find out the dot product of the two vectors, where a dot product b is equal to a times b times cosine of theta, where theta is the angle between the two vectors. With that in mind, if you can find out the cosine of theta and then apply a cos of theta, we can find out the angle in degrees. And that's exactly what we are going to do, center up vector dot product cursor direction, which is equal to the cosine of theta. But where are the absolute values of the vectors? Since both were normalized, their values are equal to 1, which can be excluded from multiplication. That said, we're left with the value of cosine of theta. From here we can apply a cos and find theta. Right now there's one problem, we can only get values from 0 to 180, which isn't enough. We want a full 360 degrees of rotation, so for that we will multiply the value of the angle with -1 if the x coordinate of the cursor is less than width divided by 2, or 1 if the coordinate is greater or equal to width divided by 2. Knowing this, we can easily orientate an image to look at the cursor of the player. With that out of the way, let's position items around a fixed point. N is going to be the number of items and I is going to be the index of the current item starting from 0. First, we are going to calculate what value we need to add for each item in degrees in order for them to be placed perfectly around the point. For that, we will divide 360 by n and multiply it by I. Then from here we will subtract 90 because the first item has I equal to 0, so in the end the value is 0, but I want the first item to always point upwards, and therefore we have to subtract 90. Knowing this angle, we will rotate the horizontal vector OZ by it, where Z is equal to width divided by X and 0, where x is theoretically any number between 1 and 2. This way we know the direction which the item should face. Then to this rotated vector we are going to add OM, the same vector as before, and subtract the size of the item widget divided by 2, so the widget is centered as well. To select an item we will have to make an algorithm that decides which item we are hovering. Firstly, we have to convert the degrees from minus 180 up to 180 to 0 up to 360. There's a simple fix to that. We pick the current value if it's above 0, or pick 360 minus the current value if it's below 0. Then from this value we subtract 180 divided by the number of items. With this we divide it by 360 divided by the number of items, floor the result, add 1, and then subtract the number of items if the result is equal to the number of items, or subtract 0 if it's not. This part is not very easy to explain, so instead of missing some dumb stuff, we will take 2 examples and apply the algorithm above. For both examples, we will have a number of 6 items, though the algorithm doesn't really care how many there are. It is going to work for any number that doesn't break the system. Keep in mind that the starting index is 0 and that items are disposed from left to right as the index increases. First of all, let's get an angle of 10 degrees relative to the center up vector. Working through the algorithm, converting to 360 degrees will return 10 degrees, from which we subtract 180 divided by 6, that means 30, returning minus 20. We divide this number by 60 and we will have in the end minus 0.33, which by flooring transforms into minus 1, and by adding 1 we get the index 0. And that's the index for the first item, which is indeed the one we were looking for. For an angle between 0 and minus 30, the item returned should be the same. That happens because the return value after flooring is 6, which is equal to the length of the array. Theoretically, the item represents the first item with index 0, so we will automatically get that from the array, otherwise we will get an error. And this algorithm works for any angle. If you want to test it, just get a random number and go through it. Lastly, designing the front end of the system is up to your UI designer or yourself if you're one. Now that we are done with theory, let's see a real example of how I implemented this into Unreal Engine 4 using blueprints so everyone can follow along the logic. Disclaimer, you should never ever do this in blueprints. Why? The performance is atrocious, there are many calculations involved every frame and blueprints don't really like that. But if you want to fiddle around with the code I created, the project files will be available for free over my Patreon page. Before starting, I want to mention that this is not going to be a complete tutorial, I'm only going to show what I have created, and in fact it's not even a complete system, you will still have to add functionality and whatnot. Before starting, let me show you what I have created. Once I'm going to hold down my middle mouse button, you're going to be able to select an item, you're going to see the name in the middle, the quantity below the image, and then this tint effect on the image. Nothing too special, but the system is there, and for the front end, that means how it looks, you can do that yourself. Okay, for the item, here's the image and the quantity, which is going to be set by a variable, this variable amount. Okay, and there's nothing too special in here, we don't have to care about that. Let's go to the Radial menu, which is where everything happens. This is a text block which is going to be set again by a variable that is going to be the name of the selected item, and then the cursor, which is currently invisible, but it is a material that looks something like this. Just a texture sample, which might not look like something special, but it actually is. It's this shape, which is a target, I believe. Okay, and in final color, I just plug in the RGB and then I set the opacity with alpha. Alright, then for the graphic, where everything happens, let's first start with getting the angle in between the up-center vector and the mouse position. There's nothing uncommon from here. It's exactly the algorithm that we talked about in the beginning. We're going to make a vector according to the positions of the mouse, and then from here we're going to subtract the center point of the viewport, which is right here. We're going to subtract it and normalize so we can only keep the direction. Then with this we're going to make a dot product using that subtraction again from the horizontal vector and the center point. Normalize this, and now using this handy node, we can get the value of the angle in degrees already, so we don't have to convert from radians to degrees. Okay, and then we are going to multiply this with -1 if the x coordinate of the mouse is below half of the width, or multiply with 1, so it's going to be the same value if it's above or equal to width divided by 2. Set this in a variable and then use it later to set the render angle of the cursor. Okay, here is how we select the items, but first let's see how we set the items around the center point, around the middle of the canvas. So we're going to have an array of items, which is going to hold a struct, and the struct looks like the following: a name, an image, and an amount, the quantity, right? This is a texture, and this is a string. Now for each, we are going to create child and add it to the canvas, right? Nothing too important here. What's interesting is the position, the same algorithm as we talked before. We're going to get the index, and then multiply this by 360 divided by the length of this array, right? And then here is the subtraction, minus 90. If this is going to be 0, not only that the system is going to break, but the item is not going to be on top anymore, right? You can see how it breaks because it's not there anymore. But if I were to put in here minus 90, you're going to see that it's on top once again. Now it works. Close this down, and then we are going to rotate that horizontal vector by this angle. As you can see, here's that division between 1 and 2. If this was going to be 1, then the items would be too far apart from the center. If this was 2, then they would be too close to the center, and now even the text would go over the cursor. So 1.75 is fine for me. This always depends on your needs and on your project. Okay, then we are going to add the center of the screen, so they're going to be in the middle. Otherwise, that is not going to work. As you can see, they're not in the right place. Okay. And now here's that subtraction with half of the image size, of the item size, I mean. Because if we plug this directly in here, you're going to see that these are aligned based on the top left anchor point. So we don't want that. Okay, so that's about positioning. Let's go to this find current item, which is the same algorithm that we talked before. Here's how you can convert from minus 180 up to 180 to 0 and 360. Okay, and the same thing, we subtract and divide and floor, add 1, and here is how you decide if you want the first item or the last item, the first item or anything else, right? Okay, that happens, and then we are going to make sure that this is different from the current item that we already have, because then we would do everything from here would be useless, right? So if I only hover the same item, there's no point in having the same algorithm again and again. Okay, and then this doesn't really matter. It's setting the color of the item, of the text, different when selecting a new one. And that's basically everything. It's not too hard to create and everyone can do it. All in all, whether you're the game developer or the player, Radial menus are cool. They are both fun and a headache to create, and the player will have a great experience using it if done well. It is one of the most versatile systems out there with countless possibilities when it comes to customization and design. And as always, thanks for watching. I want to give a huge shout out to all my patrons for supporting me this month, and not only, and especially to these top tier supporters: Aaron Skinner, Badr Al-Kahtani, Dark Lake NY, Fracture Labs, Redvine Groove, and Xim369. For more resources regarding this video, make sure to visit its description. Once again, thank you so much for watching. See you again soon.